a very interesting question which we are trying to solve today. This was part of the Leetcode Contest, and this week we basically need to find the minimum number of magic beans which we have to remove out of this array which we are given as input, so that all the bags having non-empty beans will have same number of beans. So if I'll just go through the examples one by one, I have listed this down here so that it becomes more clear. So first example is the beans we have is 4165. The optimal way of making all the beans in the non-empty bags same would be, first of all, we can make this one as 0 so that the array becomes 4065. Next thing we would do is reduce this 6 to 4, so that this 4 becomes equal to this 4. And the last thing which we would have to do is reduce this 5 to 4. So now we can see that the array has all 4s wherever the bag is non-empty, and a 0 where the bag is empty. So the total operations which we took in order to make this kind of an array from this array is like firstly reducing it, so one operation here. Second thing, reducing 6 to 4, which took us 2 operations. Then lastly we had to remove this 1 bean from 5, which would make it 4. So total 1 plus 2 plus 1, which is 4. The other example is 2, 10, 3, 2. Here the optimal way for us is in this fashion. We are making this 2 down to 0. Second step, we are like converting this 2 to 0 again, which is taking again 2 operations. And lastly we are converting this 3 which is remaining here and converting it into 0. Overall operations which took us to reach this array from here is firstly removing this 2, then removing this 2, and finally removing this 3. Overall 2 plus 2 plus 3, which is 7. So one more thing to take care of here is the size of the array. Size of array beans is roughly, it could be about 10 power 5. So this makes things very clear for us that a solution of the complexity n square n power 2 will never work. We have to either work with a solution of O(n) complexity or n log n somehow. Let's try to make it like go one by one further down from O(n) square, because we are sure that O(n) square will not work. It will become 10 power 10, which would exceed the 10 power 8 limit, which is the maximum number of operations our machine can do within 1 second. So any complexity greater than n log n will give us time limit exceeded. So the approach which I can think about here is, we have to make all the elements in this array equal to one of the existing elements in the array. We are sure that we cannot increase the value of we cannot add any bean to any bag because it is there in the constraint of the question, but we can always reduce the number of beans in a bag to make it equal to some lower value of beans in another bag. So it makes sense that we can try out each one of these elements in the array and try making all the other beans in the other bags equal to one of the elements which we have chosen. So the question boils down to choosing the element from the array itself and making all other elements not equal to given element equal to it. So let's just analyze what we have to do. For example, if I just take 4 as the reference variable, so in a way we want our array to be something like 4 0 4 4 in this example 4165. So this is the example. I am assuming that I will make all the non-zero elements in the non-empty bags have exactly 4 beans. In that scenario, what I have to do, 4 is already 4, so I don't need to do anything for this. 1 is something which I cannot make as 4 because I don't have any extra bean which I can add to this 1, because it will violate the constraint of the question. We cannot add any beans to any existing bag. All we can do is we can reduce it. So since we cannot make 1 equal to 4, we have to reduce it to 0. So 1 will be reduced to 0. In case of 6, we can reduce it by 2 to make it equal to 4, and in case of 5 we can reduce it by 1 to make it equal to 4. So in a way it's very clear that the algorithm would be, I would try each element in the array as my final number of beans in the non-empty bags, one by one. Okay, one by one, to make a smaller number equal to our reference element, we make it 0, and to make a larger element equal to our reference element, we reduce that element. In a way, we are doing A of I minus reference number of operations to do that. Now coming to the implementation, having the exact same the method which we have derived here, we will check for each of the other, we will try to implement this. So this is the implementation that we have here. I will just go through it one by one. So this is a minimum removal function. We have the input as beans here. I sort this number. So this sorting is what we are trying to do in order to make our life easier. Since there is a constraint here that we can't go at the ON square level, we have to make the elements sorted so that we can use some information which we derived from some previous computation. So I'll come back to it. We are just sorting the beans here, so this will become 1465. So that way, I will try with 1 first, since 1 will be the first element after sorting this array. Okay, this is something which you can ignore. This is something which I tried the first time when I tried this question. Okay, this is the main count which we want to maintain, and we will finally return this as the answer also. Main count of the operations that we perform. We will store some prefix sum here. Prefix sum is basically the element at current position plus the element that we have the sum of elements which we have already accumulated till the previous index. This is a very simple way of computing the prefix sum of the array. Prefix sum, till the position after sorting this 4165, it would become 1465. Prefix sum would then be 5 plus 6, which is 11, and 11 plus 5, which is 16. Okay, and finally we have some map here storing the count of operations which we have to perform, keeping each one of these elements as references one by one. We would be finally looping over this map and trying to find out for which of the reference variable we found the minimum count, and we will return that minimum count whatever we find from this loop. So okay, so what we do here is very simple. We loop over the sorted beans one by one. One by one we reach each of these elements. We try to make that element, and that is, for example, if I is 0 or like whatever I we have reached, our reference element would be beans of I, the element at position I. Now what I am trying to do here is I am trying to do the same thing here. If 1 is our reference variable, after sorting the 1 would come at the forefront, so 1 would be our reference variable. So we basically want to make all the other elements equal to 1, or if it is not possible, equal to reference, or if it is not possible, we make it 0. So that's all what we are doing here. So PrefixSum basically tells us that any element before this reference variable, since we have already sorted this beans array, will always be less than this reference variable. So all the elements which are before this index I are less than reference variable. So we can assume that we'll have to make all those elements 0. So the operation which we would take in order to make all of those elements 0 would be simply the PrefixSum till index I minus 1. Okay, and the post sum basically tells us that any element which is after this reference variable would be greater than or equal to this reference variable itself. So to get the total, we basically need to get all the sum of all the elements till this will give us the entire sum of the elements in the array, which would be 16 here. Okay, and I would then remove the elements, the sum of elements till index I minus 1, which is basically the sum of all elements which are smaller this reference variable. Okay, once I've removed them, I will just basically try to subtract the beans I, because what we are trying to do in the post part of the question is all the elements which are greater than reference, we are trying to make them reduce them to reference. For that we have to do some operations which would be the element itself minus reference. Okay, these number of operations we have to do. Since there are since the sum of all the elements after the reference variable is we have computed this way, we'll have to reduce the reference variable these number of times to get that post sum. Finally, the count of operations taking beans of I as the reference element would be PrefixSum plus PostSum. Yeah, that's it. And finally we loop over all these elements in the map and try to get the minimum count which we could obtain keeping each of these elements as reference. So that's it.